Did you know the ocean hides worlds more mysterious than space? Beneath the waves, thousands of underwater volcanoes are constantly creating new Earth. Deep-sea creatures glow like living stars, and invisible currents move heat across the planet like a giant conveyor belt. Some animals communicate with light, others navigate using Earth's magnetic field, and in the darkest trenches, life survives without sunlight at all. So take a slow breath, let your mind drift, and allow these sleepy science stories to guide you gently into the calm, hidden wonders of the deep ocean. Hello and welcome back to Dreamy Science Stories. Tonight, we'll begin a slow and soothing descent beneath the surface of our planet's most mysterious realm, the ocean. A world without borders, a vast, breathing universe of water that covers more than 70% of Earth, yet still feels endlessly unknown. Far below the shimmering waves, time moves differently. Ancient shipwrecks sleep in silence. Mountains rise where no human eyes can easily see. Creatures glow softly in the dark like drifting stars, and hidden ecosystems flourish in places where sunlight never reaches. So settle in now. Let your shoulders relax. Let your breathing slow like the steady pull of the tides. Whether you've come to learn to unwind or simply to drift gently towards sleep, these calming ocean truths will guide you through wonder and into peace. And so, our journey begins. One of the most astonishing things about the sea is that it may hold more history than the land itself. When we imagine the past, we often picture ruins standing beneath open skies, ancient temples, forgotten cities, weathered stones. But beneath the ocean's surface lies an even greater archive. Over thousands of years, countless ships have vanished into storms. Harbors have sunk beneath rising waters. Entire settlements have been swallowed by the sea. And down in the deep, these places remain preserved, almost like time capsules. In the cold, low-oxygen darkness, decay slows dramatically. Wood, pottery, metal, even delicate artifacts can survive far longer than they ever could on land. Divers and researchers have uncovered Roman cargo ships resting quietly on the seabed. And near Greece, the submerged city of Pavlopetri stands as one of the oldest underwater cities ever discovered. Today, with sonar mapping and underwater robots, archaeologists are beginning to reveal these hidden chapters of human history. Stories that have waited undisturbed for centuries beneath the waves. And then there are creatures so strange, they almost feel like myths. Some jellyfish, for example, may never truly die. Most living beings age in one direction, from youth to adulthood, and eventually to an ending. But one species, known as Turritopsis dohrnii, often called the immortal jellyfish, can reverse its own life cycle. When injured, stressed, or growing old, it can transform its cells back into an earlier stage, returning to a youthful form, as though pressing a reset button on life itself. This process, called transdifferentiation, allows the jellyfish to begin again, and again, potentially forever. Unless taken by predators or disease, it may escape aging entirely. A quiet reminder that the ocean still holds biological mysteries beyond imagination. In the underwater world, even identity can be fluid. Many fish species have the remarkable ability to change their sex as they mature. This phenomenon, called sequential hermaphroditism, allows fish to shift from male to female, or female to male, depending on their environment. Clownfish, for example, are born male. But if the dominant female disappears, the largest male will transform into a female, ensuring the group can continue. Other species do the opposite, beginning life as females and later becoming males. It's an extraordinary kind of adaptability, a reminder that life beneath the waves follows rules far more flexible than those on land. And speaking of scale, the largest mountain range on Earth is not on land at all. It lies underwater. The mid-ocean ridge system forms a continuous chain of mountains that wraps around the planet like a seam, stretching more than 65,000 kilometers. far longer than the Andes, longer than the Himalayas. These underwater ridges are places where tectonic plates slowly pull apart and new ocean crust is born. Even in the deep, the Earth is always moving, always reshaping itself in silence. Some of the fastest growing forests on Earth also live beneath the sea. Giant kelp, a type of marine algae, can grow more than a meter in a single day. Imagine that, an underwater canopy rising rapidly toward the surface, forming vast kelp forests that sway with the currents like slow-motion trees. These forests become shelter for fish, nurseries for marine life, and feeding grounds for countless species. They also absorb carbon from the atmosphere, playing a quiet but powerful role in regulating Earth's climate. Even underwater, life builds ecosystems as rich and complex as any rainforest. And hidden in the water itself is treasure beyond measure. The ocean contains more gold than all the mines on land combined. An estimated 20 million tons of dissolved gold drift invisibly through seawater. But it is spread so thin, only a few parts per trillion, that extracting it remains impossible with today's technology. For now, this golden wealth remains untouched, a silent reminder that the sea holds riches we can scarcely comprehend. The deepest part of the ocean is deeper than Mount Everest is tall. In the western Pacific lies the Mariana Trench, and within it, Challenger Deep plunges nearly 11 kilometers beneath the surface. If Mount Everest were placed there, its summit would still be covered by more than a kilometer of water. Down at that depth, pressure becomes unimaginable, over 1,000 times greater than at the surface. And yet life still exists there. Strange organisms, adapted to crushing darkness, continue to thrive, proving again that life finds a way, even in Earth's most extreme places. Perhaps the greatest mystery of all is how little we've truly seen. More than 80% of the ocean remains unexplored and unmapped. A vast unknown world of trenches, ridges, plains, and ecosystems still waiting in darkness. With drones, submersibles, and remote technology, we are only beginning to uncover new species and geological wonders. The ocean remains one of the last great frontiers on Earth. Even along the coasts, intelligence shines through. Sea otters are among the few animals known to use tools. They dive to the seafloor to collect clams, mussels, and sea urchins, then carry rocks with them, cracking shells open with careful skill. Young otters learn by watching their mothers. A gentle culture passed through generations. Even in the waves, learning and tradition exist. And the ocean is home to more species than the land could ever hold. From microscopic plankton drifting like dust motes, to the largest whales ever to exist, the sea contains ecosystems of staggering diversity. Coral reefs, though covering less than 1% of the ocean floor, support nearly a quarter of all marine species. They are the rainforests of the sea, built slowly by tiny coral polyps, forming vibrant underwater cities of color and life. But they are fragile too, sensitive to warming waters and acidification, making their protection one of the most important challenges of our time. And still, beneath the waves, underwater volcanoes continue to shape the planet, creating new land, altering ocean chemistry, and feeding deep-sea life in places where sunlight never reaches. And our journey has only just begun. Beneath the ocean's surface, the seafloor is scattered with thousands upon thousands of underwater volcanoes, most of them hidden along the shifting edges of tectonic plates, where the Earth's crust slowly pulls apart or presses together. These submarine volcanoes are far from silent. Many erupt continuously, releasing molten lava into the cold darkness. The lava cools almost instantly, hardening into fresh rock, and over long stretches of time, these eruptions create entirely new ocean crust. Layer by layer, century by century, the seafloor is rebuilt. Some eruptions grow into underwater mountains. Others rise high enough to eventually become islands. Quiet reminders that even beneath miles of water, the planet is always alive, always reshaping itself. But volcanic activity does more than create land. It also releases minerals and gases into the surrounding sea, subtly changing ocean chemistry and feeding ecosystems that feel almost alien. Near these volcanic regions, hydrothermal vents open like cracks into Earth's interior, releasing superheated, mineral-rich water into the abyss. And here, in complete darkness, life thrives without sunlight. Instead of photosynthesis, these communities depend on chemosynthesis, where bacteria transform chemicals like hydrogen sulfide into energy. From this invisible foundation, strange creatures flourish. Towering tube worms, giant clams, ghostly fish. A hidden world proving that life can bloom even in the harshest extremes. And as we drift deeper into the ocean's mysteries, we discover that the sea is always moving, not only in waves, but in currents so vast they circle the globe. One of the most important is the ocean's thermohaline circulation, sometimes called Earth's Great Conveyor Belt. This is a slow, powerful system driven by differences in temperature and salinity. Warm, salty water flows from the tropics toward the poles, where it cools, becomes heavier, and sinks into the deep. Then, far below the surface, this cold water begins a long journey back toward the equator, traveling along the ocean floor in an endless global loop. This circulation distributes heat, oxygen, and nutrients around the planet, helping regulate Earth's climate and sustaining marine ecosystems. And scientists know that if this system were ever disrupted, weather patterns and ocean health across the world could change dramatically. In the deepest regions of the sea, sunlight disappears entirely. And yet, the darkness is not empty. Many deep-sea creatures have evolved a remarkable ability. They can create their own light. Through a process called bioluminescence, chemical reactions inside their bodies produce a soft glow, like living stars suspended in black water. This light can attract prey, send signals, or confuse predators. The anglerfish carries a glowing lure above its mouth, drawing unsuspecting animals closer. Some squid flash bursts of light to startle attackers. Certain jellyfish shimmer gently, as though breathing illumination into the abyss. Bioluminescence is one of the ocean's most haunting adaptations, a reminder that even in darkness, life finds ways to shine. And the ocean is home to creatures of unimaginable scale, animals so large they make dinosaurs seem small. The blue whale is the largest animal known to have ever lived, growing up to 30 meters long, weighing as much as 200 tons, roughly the weight of 33 elephants. Yet despite their size, blue whales feed almost entirely on tiny krill, consuming several tons each day during feeding season. Their hearts are as large as small cars. Their voices travel across vast underwater distances, low songs echoing through the deep like ancient music. They are living proof of the ocean's immense capacity for life. Even the ocean's saltiness holds secrets. Seawater is not equally salty everywhere. Salinity changes depending on evaporation, rainfall, temperature, and freshwater input. The Red Sea, for instance, is among the saltiest places in the world, where evaporation is high and rain is scarce. Meanwhile, the Baltic Sea is much less salty, diluted by rivers pouring in fresh water. These differences matter deeply. Salinity affects water density, which shapes currents, and determines where certain marine species can thrive. Salt, in its quiet way, helps guide the movement of the entire ocean. Some coral reefs are so ancient, they have been growing for more than 10,000 years. These reefs have survived shifting sea levels, changing climates, and the slow turning of geological time. Built by tiny coral polyps, they form vast structures that support nearly a quarter of all marine species. They protect coastlines from storms, provide food and shelter, and hold ecosystems as complex as any rainforest. But today, warming waters and pollution threaten these ancient living worlds, making their conservation more urgent than ever. And among all reefs, one stands as the largest living structure on Earth, the Great Barrier Reef. Stretching over 2,300 kilometers off Australia's coast, it is so immense it can be seen from space. Billions of tiny coral organisms have built it over thousands of years, creating a shimmering underwater universe of fish, corals, turtles, and marine mammals. It supports tourism, fisheries, biodiversity, and shields coastlines from erosion. Yet it too faces grave threats from bleaching and climate change, a fragile wonder in need of protection. The deep sea itself is the largest habitat on Earth by volume. Everything below 200 meters, the cold, dark realm of crushing pressure, makes up over 90% of the ocean's water. It is home to countless creatures adapted to extremes, many still unknown to science. And despite covering more than half the planet's surface, it remains one of the least explored places on Earth. The deep sea is still a frontier, a vast world waiting in darkness. But not all ocean regions are full of life. Some become dead zones, areas where oxygen levels drop so low that most marine animals cannot survive. These hypoxic zones often form when nutrient pollution flows into the sea, fueling massive algae blooms. When the algae die and decay, oxygen is consumed, leaving the water suffocatingly empty. Dead zones can devastate fisheries and ecosystems, and they have been growing worldwide, a reminder that the ocean's balance is delicate and deeply connected to human activity. Hydrothermal vents, once again, challenge everything we thought life required. Here, without sunlight, ecosystems thrive on chemistry alone. Bacteria form the base of the food chain, supporting strange and beautiful life forms that seem almost extraterrestrial. These places hint that life might exist in similar environments beyond Earth, on moons like Europa or Enceladus, where oceans may hide beneath ice. And among the ocean's giants, the sperm whale holds another record, the largest brain of any animal, weighing around 7 kilograms. This immense brain supports complex behaviors, social structures, and deep intelligence. Sperm whales dive more than 2,000 meters, hunting squid in the dark using echolocation. They navigate the abyss through sound, living in societies as mysterious as the deep itself. Even the ocean's waves carry wonder. Wind-driven waves can travel thousands of miles across open water, losing surprisingly little energy. Storms in the Pacific can send swells all the way to Hawaii or distant shores of California. These traveling waves shape coastlines, influence navigation, and remind us that ocean energy moves across the planet like a slow heartbeat. The ocean also plays a crucial role in Earth's climate. It absorbs around 30% of the carbon dioxide humans produce, acting as a vast carbon sink. This helps slow global warming, but it also leads to ocean acidification. As seawater becomes more acidic, organisms that build shells or coral skeletons may struggle, changing ecosystems from the smallest plankton to the largest reefs. And beyond what it absorbs, the ocean already stores nearly 20 times more carbon than the atmosphere itself, a hidden reservoir shaping Earth's future. And still, as we float through these endless truths, the ocean feels even more vast, more mysterious. A world beneath the waves that holds history, chemistry, life, and wonder beyond measure. The ocean holds an immense reservoir of carbon, quietly shaping the balance of Earth's climate. This hidden store plays a vital role in regulating global temperatures and atmospheric chemistry. Tiny marine plants, especially phytoplankton, absorb carbon dioxide through photosynthesis, turning sunlight into life. And when these microscopic organisms die, their carbon-rich bodies drift downward like marine snow, sinking into the deep. There on the seafloor, that carbon can remain locked away for centuries, sometimes far longer. This natural system helps steady the planet's carbon cycle, yet it is also sensitive. Environmental shifts, warming waters, and changing chemistry can weaken this balance. reminding us how closely ocean health and climate stability are intertwined. Phytoplankton themselves follow rhythms as vast as the sea. Across the year, their populations explode into seasonal blooms so enormous they can be seen from space, swirling green and turquoise patterns across the ocean's surface. These blooms appear when sunlight and nutrients align perfectly, allowing phytoplankton to multiply rapidly. They form the foundation of marine life, feeding everything from tiny fish to whales. But blooms can also turn dangerous. Some become harmful algal events, producing toxins that affect marine ecosystems and even human health. Satellites now watch these shifting blooms from above, helping scientists track the pulse of ocean life on a global scale. Along tropical coastlines, mangrove forests stand as quiet guardians between land and sea. Their tangled root systems grip the shoreline, stabilizing sediments and softening the force of waves. During storms and rising tides, mangroves reduce erosion and protect coastal communities, like living shields. But their role goes even deeper. Mangroves are extraordinary carbon sinks, storing immense amounts of carbon in their wood and soils, often more per area than forests on land. They also provide nurseries for fish, sanctuaries for birds, and shelter for countless species, making them essential ecosystems for both biodiversity and climate resilience. Far beyond the coasts, the ocean drops into deep trenches, some of the least explored places on Earth. The Mariana Trench, the Tonga Trench. These narrow valleys plunge thousands of meters into darkness, where pressure becomes almost unimaginable. These realms remain largely inaccessible, not because they are empty, but because they are so extreme. And yet, life persists. Strange creatures adapted to crushing depths have been discovered there, hinting at ecosystems still unknown. Exploring these trenches reveals the limits of biology and the hidden geology of our planet's deepest scars. In recent years, scientists have observed an unusual phenomenon in the Pacific, a massive patch of warmer than normal water known as the blob. Stretching across hundreds of miles, this warm pool disrupts currents, alters marine habitats, and changes the behavior of sea life. It has been linked to unusual weather patterns along the west coast of North America, including droughts, shifting storms, and altered fish migrations. The blob is a reminder that even subtle temperature changes in the sea can ripple outward, touching ecosystems and climates far beyond the water itself. The ocean is not only mysterious, it is also powerful. Its tides and waves hold enormous potential as renewable energy sources. Tidal power captures the predictable rise and fall of the sea, driven by the moon's gravity, using underwater turbines to convert motion into electricity. Wave energy draws from the constant up and down breathing of the ocean's surface, offering promise for clean energy along coastlines. These technologies could one day support sustainable communities, though challenges remain in scaling them safely while protecting marine environments. Sometimes, the ocean reveals its magic in light. Along certain shores, bioluminescent algae create a phenomenon called sea sparkle, a glowing shimmer that ignites when waves disturb the water. At night, each step, each splash, each rolling tide can trigger soft blue-green flashes, as if the sea itself is scattered with stars. This natural glow may help deter predators or attract mates. But to humans, it feels like pure wonder, a brief glimpse into the ocean's luminous secret life. Yet not all ocean changes are so beautiful. Microplastics, tiny fragments less than 5 millimeters wide, are now found everywhere. From surface waters to deep-sea sediments. They come from broken-down waste, synthetic fibers, and everyday products. And they move silently through food webs. Plankton ingest them. Fish consume them. Even whales carry them. Microplastics can cause physical harm and introduce toxins into marine ecosystems, becoming one of the growing threats to ocean health and the safety of seafood humans rely on. And still, the ocean gives us something essential with every breath. It produces more than half of the oxygen in Earth's atmosphere. Forests may be celebrated as the lungs of the planet, but the ocean's true oxygen makers are microscopic. Phytoplankton, drifting in sunlit waters, continuously transform carbon dioxide into oxygen. Though invisible to us, they are among the most important organisms on Earth, supporting marine food webs and shaping the air itself. Without them, life would look very different. Ocean currents also shape the planet's climate like invisible highways of heat. They move warm water from equatorial regions toward the poles, and return cold water back toward the tropics. The Gulf Stream, for example, carries warmth across the Atlantic, keeping Western Europe far milder than other places at similar latitudes. These currents regulate weather patterns worldwide, and shifts in them can lead to extreme climate events, from droughts to cold snaps. The ocean is always moving, and the atmosphere listens. Beneath the surface, the ocean even has its own weather. Swirling underwater vortices form like hidden tornadoes, when currents collide or spin around obstacles. These rotating columns of water can stretch for miles, mixing nutrients, redistributing heat, and shaping marine habitats. They remind us that the ocean is not a still place, but a dynamic world of motion, turbulence, and unseen storms. Far below, the seafloor opens into abyssal plains, some of the flattest places on Earth. These vast, silent expanses extend for thousands of kilometers, formed by sediments settling over millions of years. They lie between 3,000 and 6,000 meters deep, in darkness and crushing pressure. Yet even here, life endures. Communities of strange animals have adapted to this remote environment, making the abyss not empty, but quietly alive. At the planet's poles, massive ice sheets hold frozen water that shapes the oceans themselves. Antarctica and Greenland contain enough ice to dramatically raise global sea levels if melted. When ice melts, fresh water flows into the sea, changing salinity and density, and those changes can disrupt currents, ecosystems, and climate patterns worldwide. Polar ice and ocean health are inseparable, a reminder that the planet is one interconnected system. In the ocean's predators, evolution has created extraordinary senses. Some sharks can detect the faint electrical fields produced by other animals, even prey hidden beneath sand or in murky water. This ability, called electroreception, comes from special organs known as the ampullae of Lorenzini, allowing sharks to hunt with uncanny precision. It is one of nature's most remarkable survival tools, proof that the ocean shapes senses beyond our imagination. And between the sunlit surface and the deep abyss lies the mesopelagic zone, often called the twilight zone. From about 200 to 1,000 meters down, light becomes dim and ghostly, too weak for photosynthesis, yet still present enough to create an eerie blue glow. This is a realm of daily migrations, where countless creatures rise at night and sink again by day. A world suspended between brightness and darkness, between the familiar and the unknown. And as we drift through these ocean truths, you can feel how vast and alive this underwater planet truly is. A breathing, shifting world of light, chemistry, currents, and mystery, still holding secrets in every depth. So let your thoughts float gently, like plankton in a calm sea, and allow the ocean's quiet wonder to carry you onward. Many creatures living in the twilight zone have evolved in extraordinary ways to survive in dim, fading light. Their eyes are often enormous, designed to gather even the faintest traces of brightness drifting down from above. And when darkness becomes complete, some animals create their own glow, through the quiet miracle of bioluminescence. Soft flashes and shimmering signals are used to communicate, to lure prey closer, or to vanish through camouflage in the blue-black deep. This mysterious zone is more than just a middle layer. It is a living bridge between the sunlit surface and the abyss below, a place where ecosystems thrive in half-light, adapted to a world that feels forever suspended between day and night. Once each year, coral reefs participate in one of the ocean's most breathtaking synchronized events, a phenomenon known as coral spawning. Under the guidance of lunar cycles, temperature shifts, and ancient biological timing, corals release clouds of eggs and sperm into the sea all at once. Entire reefs, stretching for miles, become filled with drifting life, a glowing underwater snowfall of possibility. This mass spawning dramatically increases fertilization success and helps reefs regenerate after storms, bleaching, or time itself. It is one of nature's most delicate celebrations, essential for the survival of these vibrant yet fragile marine cities. In colder, nutrient-rich waters, another kind of underwater forest rises toward the light: the kelp forests. These towering seaweeds form dense, swaying habitats that shelter thousands of species. Fish weave between kelp stalks like birds through branches. Invertebrates cling to their surfaces, and sea mammals hunt and rest within their green corridors. Kelp forests soften wave energy, protecting coastlines, and they absorb carbon, quietly supporting both marine biodiversity and climate balance. They are among the ocean's richest ecosystems, living forests beneath the waves. In the open sea, survival often depends on speed, and squid have mastered one of the ocean's most dramatic escape strategies: jet propulsion. By drawing water into their bodies and expelling it with sudden force, squid can rocket backward in an instant, vanishing from danger in a blur of motion. This powerful burst of agility allows them to evade predators in the vast, exposed ocean. A reminder that even in water, evolution has created its own form of flight, fast, fluid, and astonishing. The saltiness of the ocean itself is the result of deep time. Over billions of years, volcanic activity has released minerals into the atmosphere and sea. While rivers have carried dissolved salts from weathered rocks on land, as water evaporates, minerals remain behind, slowly accumulating in ocean basins. The most familiar of these salts is sodium chloride, the substance that gives seawater its sharp, unmistakable taste. This ongoing process has shaped the chemistry of the seas for ages, creating the stable salinity marine life depends upon. Across the vast open ocean, many animals navigate with an invisible compass, Earth's magnetic field. Sea turtles, salmon, whales, and countless fish sense subtle magnetic cues, guiding them across thousands of kilometers of water. Some return with astonishing accuracy to the very beaches or rivers where they were born, as though the planet itself is quietly whispering directions beneath the waves. Scientists are still uncovering how magnetoreception works, but its importance for migration and survival is undeniable. Sea stars hold one of the ocean's most remarkable healing abilities: regeneration. When an arm is lost, many sea stars can slowly regrow it, rebuilding muscle, nerves, and skeleton piece by piece. And in some species, an entire new body can form from a single arm, as long as part of the central disc remains. This extraordinary resilience allows sea stars to survive attacks, and makes them a fascinating focus for research into cellular repair and regeneration. But not all ocean changes are part of nature's balance. Plastic pollution breaks down into tiny fragments called microplastics, which are easily consumed by plankton and filter feeders. These small organisms form the foundation of the marine food chain. So when they ingest plastic, the contamination begins to rise upward. Fish accumulate it, predators consume it. Even humans may be affected through seafood. This invisible pollution threatens ocean health at every level, and reminds us how urgently the tide of plastic waste must be reduced. The ocean's absorption of carbon dioxide also comes with consequences. As CO2 dissolves into seawater, it increases acidity, a process known as ocean acidification. More acidic waters make it harder for shell-building creatures. clams, oysters, crabs, and corals, to form and maintain their calcium carbonate structures. Shells weaken, growth slows, entire ecosystems may shift. Scientists monitor these chemical changes closely because the future of reefs and fisheries depends on what happens next. The ocean's surface layer, though surprisingly thin, is one of the most important places on Earth, often only a few meters deep. This sunlit mixed layer is where phytoplankton perform photosynthesis, producing oxygen and forming the base of the marine food web. It is also the primary boundary where ocean and atmosphere exchange gases, shaping climate, weather, and life itself. So much of Earth's vitality depends on this delicate skin of water, a narrow zone supporting the vastness below. Marine mammals fill the ocean with sound. Whales, dolphins, and seals communicate through clicks, whistles, and haunting songs. Vocalizations that carry identity, emotion, social bonds, and navigation. Some whale songs travel hundreds of miles underwater, crossing entire seas like messages through darkness. Researchers study these complex languages, and also the growing threat of noise pollution that can disrupt them. The ocean is not silent. It is filled with voices. Even stranger, the seafloor holds features that seem almost impossible. Underwater lakes and rivers. In certain places, dense brine pools collect in depressions, so salty and heavy they do not mix easily with surrounding seawater. They flow like rivers along the ocean floor, creating eerie shorelines in the deep. These chemical lakes host specialized organisms adapted to extreme conditions, expanding our understanding of what habitats can exist beneath the waves. Despite constant mineral input from rivers and volcanoes, the ocean's overall salinity has remained remarkably stable for millions of years. Natural processes remove salts over time through mineral deposits and the biological use of dissolved elements in shells and skeletons. This long-term balance is crucial because marine life is finely tuned to specific salt concentrations. Salinity stability also helps regulate currents and the global climate itself. Some fish experience the world in colors we cannot imagine, including ultraviolet light. UV vision helps them detect prey, spot predators, and recognize mates, using patterns invisible to human eyes. In shallow waters, ultraviolet perception enhances contrast, and may even serve as a private form of communication. This sensory diversity reveals how differently ocean life experiences reality, a reminder that the sea holds worlds beyond our own perception. And far across the deep, whale songs travel astonishing distances. Low-frequency calls can move through the ocean for thousands of kilometers, allowing whales to communicate across entire basins. These songs drift through darkness like underwater echoes of memory, connecting animals separated by vast spaces. The ocean carries sound farther than air ever could, turning the sea itself into a channel of ancient voices. And as these ocean truths settle softly in your mind, you can feel how endlessly mysterious the sea remains. A world of light and darkness, chemistry and song, survival and wonder, still unfolding beneath the waves. Whale songs are far more than haunting melodies drifting through the deep. They serve many purposes, from mating calls that echo across breeding grounds, to social bonding between family groups, and even navigation through vast, dark waters where sight is limited. Because sound travels so efficiently underwater, these massive mammals can remain connected across enormous distances. Scientists carefully study whale vocalizations, listening for patterns that reveal population changes, migration routes, and behaviors. Knowledge that helps protect these majestic voices of the sea. Ocean currents, too, carry more than warmth and life. They act like immense conveyor belts, transporting heat, nutrients, and oxygen, but also pollutants and drifting debris. Plastics and chemicals can travel thousands of kilometers, swept across oceans into remote regions. sometimes collecting into massive garbage patches far from any coastline. Because currents ignore borders, pollution becomes a truly global issue. By understanding these moving pathways, scientists can better predict contamination spread and develop strategies to heal the ocean's waters. Even the ocean's greatest predators live under delicate limits. Sharks like the great white may seem unstoppable, yet their reproduction is surprisingly slow. They mature late, often taking more than a decade to reach adulthood, and they produce relatively few offspring. This means their populations recover very slowly after overfishing or habitat disruption. Protecting these apex predators is essential because they help maintain balance across entire marine ecosystems. Without them, the food web itself can begin to unravel. On the seafloor, life depends on quieter engineers. Sea cucumbers. These soft-bodied creatures crawl slowly through the sediment, feeding on detritus, dead organic material, and tiny particles of life. As they digest this material, they recycle nutrients back into the seabed, enriching the ocean floor like gardeners of the deep. Their movement oxygenates sediment and prevents harmful buildup, supporting bacteria, algae, and the countless organisms that depend on healthy seafloor ecosystems. Without them, the delicate foundation of ocean life below could weaken. Some of the ocean's deadliest creatures rely not on size, but on venom. The box jellyfish carries toxins so powerful they can stop a human heart within minutes. Stonefish, nearly invisible against the seabed, defend themselves with venomous spines. Even cone snails, small and beautiful, fire a venomous harpoon to stun prey instantly. These poisons evolved over millions of years, complex chemical tools designed for survival. And strangely, scientists study them not only with fear, but with hope, because within these toxins may lie new medicines, painkillers, and treatments for disease. Even danger in the ocean can inspire healing discoveries. Life in the sea also shows astonishing resilience. Some marine plants thrive in extreme salinity, where evaporation leaves water far salter than most organisms could tolerate. Salt marsh plants and algae have developed cellular systems to expel or safely store excess salt. Mangrove trees, for example, filter salt through intricate root networks, allowing them to flourish where land and sea collide. These salt-tolerant ecosystems protect coastlines, shelter young fish and birds, and store immense amounts of carbon. They remind us that life can bloom even in harsh, briny worlds. Over the past century, the ocean itself has been warming. Human activities have increased greenhouse gases, and the sea has absorbed much of this rising heat. Even small temperature changes can ripple outward. Coral reefs bleach when waters grow too warm. Fish migrate toward cooler regions, reshaping food webs and fishing grounds. Warmer oceans can also intensify storms and hurricanes, influencing weather patterns across the planet. Scientists track these shifts closely because the ocean's temperature is not just a number. It is the pulse of Earth's climate system. Some sharks, like the oceanic white-tip, have gained a reputation for boldness. These powerful predators roam tropical waters, recognizable by the bright white tips of their fins. Their curious persistence around unfamiliar objects has been linked to dangerous encounters, especially in shipwreck history. Yet even these feared hunters play an important ecological role, maintaining balance as apex predators. Sadly, oceanic white-tips are now considered vulnerable, threatened by overfishing and habitat loss. Conservation matters, even for creatures we do not fully understand. The ocean is also filled with life so small it is almost unimaginable. Viruses, microscopic and invisible. Ocean viruses exist in numbers beyond comprehension, outnumbering all other biological entities combined. They infect bacteria and microorganisms, regulating their populations. And when microbes die, nutrients are released back into the ecosystem. This constant viral cycle fuels the microbial food web and influences carbon movement through the seas. Though unseen, these tiny agents shape the productivity and balance of marine life on a global scale. Coral reefs, so vibrant and alive, depend on partnership. Inside coral tissues live microscopic algae called zooxanthellae, quiet companions that perform photosynthesis. They convert sunlight into energy, feeding the coral and allowing reefs to grow in nutrient-poor waters. In return, the algae receive shelter and access to nutrients from the coral. This symbiosis is the reason coral reefs can flourish like underwater rainforests. But when stressed by heat or pollution, corals expel their algae, leading to bleaching, a fragile reminder of how easily balance can break. And far above these reefs, in polar regions, sea ice drifts across the ocean's surface. Though it covers only around 7% of the sea, its influence is enormous. Sea ice reflects sunlight back into space, helping cool the planet. It provides habitat for seals, penguins, and polar bears, and shapes global circulation patterns. As sea ice melts, darker ocean water absorbs more heat, accelerating warming in a feedback loop. The frozen edges of the ocean are not distant, isolated places. They are vital threads in Earth's climate tapestry. And as these ocean truths settle softly in your mind, you can sense how endlessly interconnected the sea truly is. From whale songs to drifting currents, from hidden viruses to shimmering ice, a world of wonder, mystery, and fragile balance, still breathing quietly beneath the waves. Scientists watch sea ice with great care, because it is one of the most sensitive indicators of climate change. A shifting sheet of frozen ocean that reflects sunlight, cools the planet, and supports entire polar ecosystems. Sea ice is far more than a distant wilderness. It is a key player in Earth's environmental balance, a fragile mirror that tells us quietly how the climate is changing. Along warm coastlines where rivers meet the sea, mangrove forests thrive in conditions that would overwhelm most plants with salt. To survive, mangroves have evolved remarkable adaptations. Their roots act like living filters, blocking much of the salt before it can enter their tissues. Any salt that does slip through is stored in older leaves that eventually fall away, carrying the salt with them. This ability allows mangroves to grow in oxygen-poor, salty mud, where few other trees could endure. And these forests do so much more than survive. They protect coastlines from erosion, provide nursery grounds for young fish, and store immense amounts of carbon, helping regulate Earth's climate. Mangroves are quiet guardians of both sea and atmosphere. In the shifting light of coral reefs, some fish possess an extraordinary gift. They can change color almost instantly, blending into their surroundings or sending signals to others. This rapid transformation is made possible by specialized pigment cells called chromatophores, which expand or contract like tiny living paintbrushes. Cuttlefish and flounder can match the seafloor so perfectly they nearly disappear, avoiding predators or sneaking close to prey. But color is also communication. Fish may flash patterns during mating displays, or shift hues in territorial disputes, a dynamic underwater language of survival and connection. Far below the surface, the deep ocean is nourished by something that looks almost like snowfall. Marine snow is a constant shower of organic material drifting down from the sunlit world above. It is made of dead plankton, algae fragments, fecal pellets, and drifting detritus. A slow, endless cascade feeding creatures in the abyss. Even in total darkness, life continues, sustained by this gentle rain of nutrients. Marine snow also plays a vital role in the carbon cycle, carrying carbon from the atmosphere into the deep sea, where it may remain stored for centuries. In shallow coastal waters, seagrass meadows spread like underwater fields. These ecosystems are among the richest carbon sinks on the planet, capturing and storing blue carbon deep in their roots and surrounding sediments. Seagrasses grow quickly, trapping particles, stabilizing shorelines, and improving water clarity. They provide shelter for fish, turtles, and countless marine creatures, and they lock away carbon dioxide that would otherwise linger in the air. Protecting these meadows is increasingly seen as a natural solution, a quiet, green ally in the fight against climate change. Some ocean partnerships are even more surprising. Certain crabs carry sea anemones on their claws like living weapons. The crab gains protection from the anemone's stinging tentacles, waving them at predators as a natural defense. In return, the anemone receives mobility and access to food scraps stirred up by the crab's movements. This symbiosis is a clever evolutionary cooperation, a reminder that survival in the sea often depends on teamwork as much as strength. Hidden among reefs, giant barrel sponges stand like ancient monuments. Some of these sponges may live for more than 2,000 years, making them among the longest living animals in the ocean. They filter vast volumes of water each day, removing bacteria and organic particles, helping keep reef ecosystems healthy. Their slow growth and layered tissues record environmental changes over centuries, like living archives of ocean history. But despite their age, they remain vulnerable, threatened by pollution, warming seas, and physical damage. Their conservation matters deeply for reef biodiversity. Even the ocean's tides shape the rhythms of life. Many marine animals time reproduction to the rise and fall of the sea, using tides and lunar cycles as precise environmental clocks. Fish, crabs, and corals may synchronize spawning events with high tides, ensuring larvae are carried away from predators and dispersed into safer waters. This tidal timing increases survival, linking biology directly to the gravitational pull of the moon and sun. The ocean's pulse guides life itself. Some fish experience the world through electricity. In murky or dark waters, they generate and detect electric fields to navigate, hunt, and communicate. Electric eels can deliver powerful shocks to stun prey, while elephant fish and knife fish emit weaker signals, using them like biological radar. This electric sense allows fish to see through impulses, an extraordinary adaptation showing how diverse ocean perception can be. Deep beneath the seafloor, natural oil seeps release hydrocarbons slowly into the sea. These may sound like pollution, but they are naturally occurring phenomena that support unique ecosystems. Specialized bacteria feed on the oil, providing energy for clams, tube worms, and other creatures. Life flourishes here using an unusual energy source, proof that the ocean can adapt even in extreme conditions. These strange communities highlight the resilience and creativity of marine life. At the very surface, where water meets air, lives a delicate world called the Nustan. This community includes tiny algae bacteria, floating sea snails, and jellyfish larvae, organisms living in the thinnest boundary layer of the ocean. They form the foundation of surface food webs, supporting larger animals and nutrient cycling. But because they exist at this fragile interface, they are highly sensitive to pollution and temperature shifts. Studying them helps scientists understand how surface ecosystems connect to global ocean health. Some of the smallest reef builders are marine worms. Species like the Christmas tree worm create intricate calcium carbonate tubes, embedded within coral structures. These tubes provide shelter not only for the worms, but also for other tiny reef inhabitants. By adding complexity, these worms increase biodiversity, acting as miniature engineers that strengthen and stabilize reef ecosystems. Even the smallest builders play an important role in ocean resilience. And above all, the ocean is never truly still. Most waves are born from wind, energy transferred across the water's surface. These waves can travel thousands of kilometers, shaping coastlines and guiding ships. But some waves have more dramatic origins. Underwater earthquakes and landslides can trigger tsunamis, massive walls of water moving at jet-like speeds, reminding us that the ocean is both beautiful and powerful, a dynamic force capable of calm and catastrophe. And as these watery wonders drift through your thoughts, you may feel the ocean's vast interconnectedness. From icy poles to tropical mangroves, from drifting marine snow to electric fish, a world of endless mystery, breathing softly beneath the waves. In some parts of the ocean, jellyfish can gather in numbers so immense that their swarms stretch for miles across the surface. These vast blooms can reshape local ecosystems, competing with fish for food, clogging fishing nets, and sometimes even disrupting coastal industries like power plants that draw seawater for cooling. Scientists believe blooms may become more common when waters warm, when predators are overfished, or when nutrient pollution enriches coastal seas. And yet, jellyfish are also ancient, natural parts of ocean life. A reminder that balance in marine environments is delicate and can shift with surprising speed. Among the ocean's gentle giants, the whale shark holds a special place. It is the largest fish on Earth, growing up to 12 meters long or even more. And despite its enormous size, it feeds not on large prey, but on tiny drifting life. With its mouth open wide, it filters plankton, fish eggs, and small organisms from the water, sifting the sea with specialized gill structures. Whale sharks move slowly through warm tropical oceans, peaceful, unhurried, a living reminder that greatness in nature is not always fierce. Sometimes it is calm, high above the waves. Marine birds travel distances that seem almost impossible. Albatrosses and petrels can cross entire oceans, not by constant flapping, but by using wind and currents as invisible highways. Through a technique called dynamic soaring, they glide effortlessly along the shifting air above waves, saving energy while traveling thousands of kilometers. In doing so, these birds connect distant marine regions, transporting nutrients, linking ecosystems, and reminding us that ocean life is not only beneath the surface, but also written across the sky. The ocean is also the heart of Earth's water cycle. Every day, vast amounts of seawater evaporate, rising into the atmosphere as invisible vapor, only to return as rain or snow across land and sea. This endless exchange fuels storms, monsoons, and hurricanes, and shapes rainfall patterns around the globe. Warm ocean waters provide moisture for weather systems, and currents help distribute that moisture, meaning that changes in ocean temperature can influence droughts, floods, and the lives of ecosystems and societies worldwide. The ocean, in many ways, is the planet's breathing source of rain. Some of the strangest adaptations in the sea belong to creatures that blur the line between plant and animal. Certain sea slugs can steal chloroplasts, the photosynthetic machinery of algae they consume, and incorporate them into their own cells. This process, called kleptoplasty, allows the slug to harness sunlight for energy, like a living, drifting solar panel. For weeks or even months, these animals can partially sustain themselves through photosynthesis, a breathtaking example of evolution's creativity and of how surprising survival can be in the ocean. Coral reefs are not only living ecosystems, they are also historical records. As corals grow, their skeletons form layers. Much like the rings of a tree, each layer captures information about ocean temperature, chemistry, and nutrient levels at the time it was created. By studying coral cores, scientists can reconstruct centuries of climate history, tracking El Niño events, long-term warming, and the progression of ocean acidification. Corals, fragile as they may be, hold within them the memory of the sea. In the underwater world, sound can travel farther than sight. Some fish have evolved the ability to produce powerful sonic blasts by rapidly contracting muscles near their swim bladders. These sounds may attract mates, establish territory, or even frighten predators. The oyster toadfish, for example, produces a haunting boat whistle call, echoing through murky waters where visibility is low. In the ocean, communication is often written not in color, but in vibration, swirling through the sea like slow storms. Ocean eddies are rotating currents that can last for weeks or months, spanning tens or even hundreds of kilometers. These spinning waters trap nutrients, bringing richness from the deep ocean up toward the surface, creating hotspots of productivity. Phytoplankton blooms flourish here, supporting fish, seabirds, and marine mammals, all gathering where the sea becomes suddenly abundant. Eddies are reminders that the ocean is never static. It is always moving life into motion. Even crustaceans, often thought of as simple creatures, can display complex behaviors. Some crabs and shrimp perform elaborate courtship rituals, dancing, flashing bright colors, or building nests to attract mates. And after fertilization, many species guard their eggs carefully, carrying larvae until they are ready to survive on their own. These acts of protection and care reveal that even invertebrate life contains patterns of nurturing and surprising complexity. Deep in the darkness of the seafloor, hydrothermal vents erupt with superheated, mineral-rich water. Here, ecosystems thrive without sunlight. Instead of photosynthesis, life is powered by chemosynthesis, where bacteria convert chemicals like hydrogen sulfide into energy. These microbes form the base of food webs, supporting giant tube worms, clams, shrimp, and creatures found nowhere else on Earth. Hydrothermal vents challenge the very definition of where life can exist, proving that even in extreme darkness, nature finds a way. Salt water, heavier than fresh water, creates invisible layering in many ocean regions. Dense, salty water sinks below lighter, fresher water, forming stratified layers that affect circulation, nutrient mixing, and the distribution of marine life. Where rivers meet the sea, distinct layers can shape plankton growth, fish behavior, and coastal ecosystems. Understanding these hidden layers helps scientists predict how oceans respond to change, and how life adapts within shifting waters. In the deep sea, some fish possess adaptations so strange they seem unreal. A few species, like the barrel-eye fish, have transparent heads, allowing them to look upward through a clear dome. Their tubular eyes can rotate, spotting prey silhouetted against faint light above, while remaining protected in the darkness. It is one of the ocean's most extraordinary examples of evolution sculpting life for a world with almost no light. And at the foundation of it all, plankton drift. These microscopic organisms may be tiny, but they sustain the entire marine food web, and they are highly sensitive to temperature. Even slight warming can shift their growth, their reproduction, and their distribution, because plankton feed fish, and fish feed seabirds, whales, and humans. Changes in plankton ripple outward, a reminder that the smallest life forms often hold the greatest influence over ocean balance, and over the living planet itself. Seasonal plankton blooms depend on a fragile harmony, a perfect meeting of sunlight, temperature, and nutrients. When conditions are just right, the ocean suddenly fills with microscopic life, blooming like an underwater springtime. But as climate change warms the seas, that delicate balance begins to shift. Rising temperatures can disrupt these cycles, altering the timing of blooms, and sending ripples through the entire food web. Because plankton feed fish, fish feed whales and seabirds, and fisheries around the world depend on this invisible foundation. When plankton blooms change, biodiversity and human livelihoods can change with them. In the deep, dark ocean, many creatures have learned to speak in light. Bioluminescence, the ability to glow through chemical reactions, is one of the most widespread wonders beneath the waves. Squid may flash sudden bursts of light, to confuse attackers. Jellyfish can emit a steady glow, blending into faint moonlight filtering down from above. Others use light to attract mates, lure prey, or send silent warnings through the water. In a world where sunlight disappears, bioluminescence becomes a language, a living constellation of survival. At the very surface of the sea, there is a habitat so thin it is almost invisible. The ocean's surface microlayer, only a few millimeters thick, forms the boundary between water and air. Yet within this delicate skin, specialized microorganisms thrive, adapted to unique chemical and physical conditions. These microbes help regulate gas exchange, cycle nutrients, and even influence cloud formation above the ocean, because it touches the atmosphere directly. This fragile layer is also highly sensitive to pollution and climate change, a reminder that even the smallest zones can hold global importance. The ocean may also hold keys to a cleaner energy future. Certain marine algae, seaweeds and microalgae, grow rapidly, converting sunlight and carbon dioxide into rich biomass. Scientists are exploring how these organisms could be transformed into biofuels, producing biodiesel, biogas, or ethanol. Unlike land crops, marine algae require no farmland and little to no fresh water, making them a promising renewable resource. Perhaps one day, ocean plants could help power the world while easing dependence on fossil fuels. But not all ocean changes are hopeful. Across the globe, dead zones are expanding. These are regions where oxygen levels drop so low that most marine life cannot survive. Often the cause begins on land. Fertilizers and sewage wash into coastal waters, triggering massive algal blooms. When the algae die, decomposition consumes oxygen, leaving behind hypoxic, lifeless seas. Climate change worsens the problem, as warmer water holds less oxygen. Dead zones threaten fisheries, reduce biodiversity, and remind us how closely human activity is tied to ocean health. Some fish, however, have evolved extraordinary resilience. Species like salmon, known as anadromous fish, can survive in both freshwater and saltwater. They hatch in rivers, migrate to the open ocean, then return, guided by instinct, to their birthplace to spawn. To do this, their bodies perform remarkable physiological adjustments, regulating internal salt balance across changing environments. But their journeys expose them to dangers in both worlds: pollution, habitat loss, and overfishing, making their survival stories even more astonishing. Far beneath the waves, the ocean hides landscapes as dramatic as those on land. Underwater canyons, carved by sediment flows and tectonic forces, plunge deeper than the Grand Canyon. Places like Monterey Canyon stretch for miles beneath the sea, funneling nutrients into the deep and creating biodiversity hotspots along their steep walls. Yet many of these valleys remain unexplored, their depths still holding secrets beyond reach. Sea turtles are among the ocean's greatest navigators. They travel thousands of miles across open water, returning again and again to the beaches where they were born. How do they find their way? Scientists believe turtles sense Earth's magnetic field, using it like a natural GPS. By detecting subtle changes in magnetic intensity and angle, they can map their position and cross vast featureless oceans with astonishing accuracy. A migration guided not by landmarks, but by the invisible pull of the planet itself. Ocean nutrient cycles are also shaped by powerful forces from below. Upwelling, the rise of deep, cold, nutrient-rich water, brings essential elements like nitrogen and phosphorus to the surface. These nutrients feed phytoplankton, supporting the entire marine food chain. Upwelling zones, such as those off California and Peru, are among the most productive fisheries on Earth. In these regions, the deep ocean breathes upward, fueling life above, yet chemistry is changing in the sea. As oceans absorb more carbon dioxide, they grow more acidic. This acidification does not only affect shells and corals, it can also alter fish behavior. Some fish lose their ability to sense predators, becoming less cautious, more vulnerable, and disrupting predator-prey relationships. Small behavioral shifts can cascade through ecosystems, changing populations, and impacting the fisheries humans depend on. Some ocean species remind us of deep time. The Greenland shark, swimming through icy Arctic waters, may live for more than 2 centuries. Slow-growing, long-lived, a creature whose lifespan stretches beyond human generations. Studying such animals helps scientists understand aging and the long-term impacts of environmental change. Across centuries, not just decades, even the ocean surface plays a role in climate balance. Water reflects part of the sun's energy back into space, a measure known as albedo. On average, the ocean reflects about 6% of incoming solar radiation. Small changes in surface conditions, waves, clouds, melting ice, can alter this reflectivity, influencing Earth's energy balance and global temperature regulation. And amid the growing crisis of plastic pollution, there are small signs of possibility. Some marine bacteria have shown the ability to break down plastics, using enzymes that degrade materials like PET. This process is slow and not a complete solution, but understanding these microbes may inspire future biotechnologies, offering new tools in the fight against ocean waste. Even in the smallest organisms, there can be hope. As our voyage beneath the waves gently comes to an end, allow the vastness of the ocean to rest quietly in your thoughts. A world still moving slowly beneath the surface, full of life, mystery, and wonders we have only begun to understand. May the rhythm of tides and the whisper of unseen currents ease your mind into calm and carry you toward deep, peaceful rest. Thank you for spending this soothing journey with Dreamy Science Stories, where curiosity meets comfort and science becomes a soft place to drift. Sleep well, stay gently curious, and until next time, let the ocean's embrace remain with you. Good night.